Something happened today that should not be possible, and if you understand the physics behind it, you'll realize why there is no calm explanation for what we are seeing. It is March 3rd, 2026, and 4 hours ago, at exactly 14 UTC, the rules that govern our solar system failed in a way we have never documented before. I need you to follow this carefully, because the event I'm about to describe has a 0% probability of being natural. At 14 UTC, NASA's Deep Space Network and the Goldstone Radar Facility detected a signal separation coming from the object known as 3I Atlas. For months, Atlas was classified as a comet, nothing more than a passive chunk of ice and rock tumbling through space. That assumption ended today. The data now on my screen forces a very different conclusion. Imagine watching a car drive down a highway. If a small piece breaks off, physics tells us exactly what should happen. That fragment loses energy, tumbles away, and drifts off unpredictably. This is the law of conservation of momentum. It is not optional. It is not negotiable. But that is not what happened with Atlas. What detached from Atlas today was not debris. It was a perfect metallic sphere. We are calling it object beta, and when it separated, it didn't drift. It accelerated. In the vacuum of space, without any exhaust plume, without any chemical or thermal signature visible to our infrared sensors, this sphere instantly increased its velocity by 12 kilometers per second. That is not falling. That is not inertia. That is a maneuver. I've spent my career studying theoretical physics and the fundamental forces that govern motion. I've reviewed the telemetry from the Jet Propulsion Laboratory and cross-checked it with data from the European Space Agency's Gaia mission. The conclusion is unavoidable. Natural objects do not perform high-g acceleration. Rocks do not change course on command. As I'm speaking to you right now, object beta is on a trajectory that intersects directly with Earth's high orbit. It is not passing nearby, it is arriving. This is why there are emergency briefings underway at the White House and the United Nations. When analysts mapped the trajectory, they found something even more unsettling. The object is targeting a stable parking position near Earth-Sun Lagrange point 1, a region where gravitational forces cancel out, allowing an uninterrupted, permanent view of our planet. This is not a collision path. This is an observation insertion. Even more disturbing are the mass readings derived from the gravitational disturbance caused during separation. Despite its small size, the sphere has a density that does not fit anywhere on the periodic table. It is heavier than lead, yet it moves with extraordinary ease. The question physicists are asking right now is not whether Atlas is unusual. That question was answered hours ago. The real question is what is inside that sphere and why it is in such a hurry to get here. To understand why this is unprecedented, we have to examine the timeline. 5 minutes before separation, at 13:55 UTC, Atlas was traveling at a standard cometary speed of 34 kilometers per second. Goldstone radar showed exactly what we expected: an irregular, tumbling body, boring and predictable. Then, at 14 UTC, everything changed. Comets do not open. When they break apart, they explode. Gas expands, ice sublimates, and debris scatters violently in all directions. That is entropy in action. But Atlas did not explode. The radar data shows a section of the main body shifting smoothly. No fracture, no debris cloud. From inside the structure, object beta emerged with mechanical precision. There was no dust, no gas, no chaos. The sphere slid out cleanly, as if released by design, and that moment marked the end of every natural explanation we had. Because what followed was not just strange, it was engineered. Engineered systems leave fingerprints, and science demands verification before drawing conclusions. In this case, verification arrived immediately. NASA's Deep Space Network recorded an abrupt Doppler shift, confirming that two distinct objects were now moving at different velocities. That alone proved separation. Moments later, the European Space Agency's Gaia telescope detected a subtle wobble in Atlas's trajectory, evidence that a significant mass had departed and altered its center of gravity. Then came the final confirmation. The James Webb Space Telescope, already tracking the region, observed a thermal anomaly at the exact coordinates of the separation. Three independent instruments, operated by different agencies, using entirely different methods, reached the same conclusion. Atlas had released something, but what Webb saw is what forced scientists to stop using the word natural. When rock fractures in space, energy is released as heat. Stress, friction, and structural failure make the debris glow in infrared light. That glow is unavoidable. Yet object beta did not glow. The readings from Webb's near-infrared camera showed something unprecedented. The surface temperature of the sphere was near absolute zero immediately after separation. It was colder than the surrounding vacuum. That detail matters more than it sounds. Heat is a consequence of energy transfer. To detach without producing heat requires either a frictionless release mechanism or active cooling capable of suppressing thermal output in real time. Both imply engineering. What we witnessed was a separation event with zero waste heat, something that directly challenges our understanding of thermodynamics. This forces a re-evaluation of Atlas itself. The evidence suggests it is not a solid rock at all, but a carrier, a structure designed to transport something else. And the behavior of object beta after release only reinforced that conclusion. Within seconds of separation, Goldstone radar attempted to resolve the shape of the object by bouncing radio waves off its surface. Natural asteroids scatter radar signals unevenly. Their surfaces are rough, fractured, chaotic. The return signal from object beta was different. It was clean, focused, coherent. That only happens when radar reflects off a perfectly smooth surface. The object was not merely spherical. It was mathematically precise, polished to within fractions of a millimeter. The radar return intensity suggested a mirror-like exterior, something far beyond any natural formation process. Nature does not manufacture perfect spheres, engineering does. And then the object did something that eliminated any remaining doubt. 10 minutes after detachment, object beta stopped tumbling. Natural objects in space rotate endlessly, their spin altered only by collisions or tidal forces over immense time scales. But this sphere stabilized itself. Its rotation slowed, then ceased entirely, locking onto a single axis. That axis was not random. Tracking data shows the object aligned itself with extraordinary precision within 0.04 degrees directly toward Earth. Not the Sunday, not Jupiter, not the galactic plane. Earth. Debris does not orient itself. Debris does not choose a reference frame. Orientation implies control, and control implies intention. At that moment, the language inside mission control rooms changed. Engineers stopped asking whether the object was artificial and began asking what kind of system it represented, because everything about its behavior pointed to a machine waking up. What came next is where the laws of motion themselves came under scrutiny. For 3 centuries, Newton's laws have described how objects move. To change velocity, you need force. To generate force, you need energy. To accelerate, you must push against something. At 14:15 UTC, 15 minutes after separation, telemetry from the Deep Space Network showed that object beta accelerated again. When it detached, it was already moving at 34 kilometers per second, a typical speed for an object falling inward through the solar system. But over the next 18 seconds, its velocity increased to 46 kilometers per second. That is a 12 km per second increase in less than half a minute. To achieve that, with conventional propulsion, would require fuel masses larger than the object itself. Chemical rockets cannot do it, ion drives cannot do it, nuclear thermal systems cannot do it, and yet the acceleration happened with no exhaust plume, no heat spike, no detectable reaction mass. The sphere didn't push anything backward, it simply moved forward. And that was the moment physicists realized they were no longer watching propulsion, they were watching something else entirely. The only way to explain motion without reaction mass is to accept that something is interacting with space itself, and that idea has lived on the fringe of physics for decades. Concepts like space-time manipulation and metric engineering were once considered mathematical curiosities, not practical tools. Yet object beta was now behaving exactly like a system that does not travel through space, but reshapes it. Instead of pushing against particles or expelling mass, the sphere appeared to alter the geometry around it, creating a gradient that space naturally fell into. From the outside, it looked like acceleration. From the inside, it may have felt like standing still while the universe moved. This is the kind of technology humans have only theorized about, and even then, only in equations that assume energy levels far beyond anything we can generate. As analysts worked to model the acceleration curve, another detail surfaced. The motion was not brute force, it was smooth, efficient, and precisely timed. The object accelerated just enough to adjust its trajectory, then stopped instantly, as if obeying a pre-written flight plan. There was no overshoot, no correction burn, no waste. Every movement had purpose. That purpose became clearer when trajectory simulations were updated. Object beta was no longer simply heading toward Earth's vicinity. It was threading a narrow gravitational corridor that required advanced knowledge of planetary positions, solar pressure, and even minor relativistic effects. This was not a path that could be calculated on the fly. It had to be planned long in advance, which raises an unsettling possibility. If this route was pre-computed, then whoever designed object beta knew where Earth would be on this exact day, at this exact hour, long before humans ever noticed Atlas entering the solar system. That implies not just observation, but prediction on astronomical timescales. Meanwhile, Atlas itself began to behave in ways that further complicated the picture. After releasing the sphere, the main body did not continue on its previous cometary path. Instead, it subtly adjusted its spin and orientation, as if responding to internal structural changes. Radar imaging revealed voids where dense material had once been, reinforcing the idea that Atlas was a shell rather than a solid object. In other words, Atlas may have been disposable, a delivery system designed to look natural until the moment it was no longer needed. As object beta sped ahead, its communications silence became the next focus of concern. Human spacecraft leak signals constantly, electronics emit noise, oscillators drift, systems hum. Even our stealthiest probes cannot completely hide their presence. Yet this sphere was silent across every band we monitored. Radio, microwave, optical, nothing. Silence can mean one of two things. Either the object is inactive, or it is using communication methods we do not understand or cannot detect. Given its maneuvering capabilities, inactivity was no longer a reasonable assumption. At 15:02 UTC, roughly an hour after separation, analysts noticed a pattern in the object's movement relative to Earth's rotation. It wasn't just heading toward a point in space. It was matching Earth's rotational frame of reference. That means it wasn't simply tracking our planet's position, but its spin, its orientation, its day-night cycle. That level of synchronization requires real-time data or an internal model of Earth accurate enough to predict its motion down to the minute. Either explanation is disturbing. This is where the conversation moved beyond physics and into intent. Machines that observe do so for reasons. surveillance systems gather data, probes analyze environments, and platforms placed at Lagrange point 1 are ideally positioned to monitor solar activity and maintain a constant view of Earth. But nothing about object beta suggested passive observation. Its acceleration profile, its precision, and its silence all implied autonomy. This was not a drifting sensor. It was an active system with goals. By now, the world's major space agencies were sharing data in real time, something that rarely happens without a direct threat. The question was no longer whether object beta was artificial or even whether it was advanced. The question was whether it was aware. And awareness, when directed at Earth, changes everything. Awareness implies decision-making, and decision-making implies criteria. The moment that realization took hold, analysts began searching for signs of response rather than motion. They wanted to know if object beta was reacting to us or simply following a script written long ago. The distinction matters because a pre-programmed system can be predicted, an adaptive one cannot. The first test came unintentionally. As news of the object's behavior spread within classified channels, several radar facilities adjusted their transmission power to probe the sphere more aggressively. The goal was to extract higher resolution surface data. Within minutes of the power increase, object beta altered its orientation by a fraction of a degree. It did not change course. It did not accelerate. It rotated just enough to reduce its radar cross-section. That response was subtle, but devastating in its implications. Rotation to minimize detectability is not passive behavior. It is a countermeasure, and countermeasures are designed in anticipation of observers. From that point forward, the object's silence took on a new meaning. It wasn't merely quiet, it was deliberately quiet. Further analysis of its trajectory revealed another detail that had been missed earlier. Object beta was avoiding certain regions of space where human satellites are densely clustered. Its path curved gently away from high-traffic orbital shells, including geostationary and low Earth orbit zones, despite those being the most direct routes. The detours were small, but intentional. That meant it wasn't just aware of Earth as a planet, it was aware of Earth as a technological civilization. As this pattern emerged, policymakers were briefed on a sobering conclusion. Whatever had arrived in our solar system possessed not only advanced propulsion, but an understanding of how we observe and how we move. This wasn't first contact in the cinematic sense. There were no signals, no messages, no grand displays. There was only quiet assessment. And quiet assessment is often how intelligence gathering begins. Meanwhile, physicists continued to struggle with the implications of the propulsion system. If object beta was indeed manipulating spacetime locally, the energy requirements should have been catastrophic. Models predicted outputs comparable to stellar processes. Yet no such energy signatures were detected. That suggested either a radically new energy source or a level of efficiency that made our technology look wasteful by comparison. Both possibilities were equally unsettling. Attention then returned to Atlas. If it was a carrier, where did it come from? Backtracking its trajectory led to a startling realization. Atlas did not originate from the Oort cloud, as initially believed. Its inbound path did not match the statistical distribution of long-period comets. Instead, it appeared to have entered the solar system from a direction significantly above the galactic plane. That direction is not random. It is a region of interstellar space that contains relatively few natural objects. To arrive from there at the observed velocity suggests deliberate insertion, not gravitational accident. In other words, Atlas may not have wandered into our system. It may have been sent. This reframed the entire event. Object beta was not a lone anomaly. It was part of a larger mission architecture. Atlas was the delivery vehicle, The sphere was the payload, and Earth was the destination. At this stage, discussions within international councils shifted from scientific curiosity to strategic concern. Lagrange point 1 is not just a convenient observation post, it is a strategic high ground in space. From there, a system can monitor solar storms, track spacecraft, and maintain uninterrupted surveillance of Earth. Placing an unknown object there is not neutral, it is a statement. Still, no hostile actions were observed, no energy buildup, no approach into lower orbit. Object Beta maintained a steady, controlled trajectory, as if following a plan that allowed time for observation, analysis, and perhaps decision. And that waiting, that patience, may be the most alarming detail of all, because patience suggests confidence. Perfect, we're locked in and the continuity is solid so far. Confidence implies superiority, or at least the belief that there is no need to rush. That assumption forced analysts to confront a possibility that had been carefully avoided until now. If object beta was waiting, then the timeline was not ours. It was theirs. As the sphere continued its controlled approach toward Earth, Sun Lagrange point 1, new data began arriving from solar observatories. The object was passing through regions of varying solar radiation, magnetic flux, and charged particle density, yet its trajectory remained unaffected. Even more unusual, instruments detected minor fluctuations in the surrounding plasma, as if space itself were being displaced and then settling back into place after the object passed through. This behavior reinforced earlier suspicions. Object beta was not shielding itself from the environment, it was altering the environment. At the same time, attempts to provoke a response grew more cautious. No one wanted to trigger an unknown system with unpredictable capabilities. Instead, agencies focused on passive observation, watching for patterns that might reveal intent. And patterns did emerge. The sphere's deceleration profile, as it neared its destination, was just as precise as its acceleration had been. It slowed gradually, aligning its velocity with the gravitational balance point between Earth and the Sunday. This maneuver required constant micro-adjustments, compensating for solar wind pressure, Earth's orbital eccentricity, and lunar gravitational influence. Every correction was perfect. Nothing about this process was automated in the way human spacecraft operate. Human systems rely on feedback loops, constant communication, and frequent error correction. Object beta needed none of that. It behaved like a system that already knew the outcome. As the object approached insertion range, its surface characteristics changed subtly. High-resolution optical telescopes detected a shift in reflectivity, as if the outer layer of the sphere was reconfiguring itself at a microscopic level. The change was not uniform. Different regions of the surface adjusted differently, suggesting adaptive materials rather than static armor. That adaptability carried an unmistakable implication. This was not a probe designed for a single task. It was a platform capable of modification in response to new data. Meanwhile, attention returned once again to Atlas, now drifting silently on a decaying trajectory away from the inner solar system. Without its payload, it showed signs of structural instability. Sections of its mass distribution no longer made sense as natural formations. It had fulfilled its role and was now irrelevant, which raises an uncomfortable thought. If this mission architecture included disposable components, then efficiency, not preservation, was the priority. And efficiency is a hallmark of advanced planning. By this point, the scientific consensus had converged on a single conclusion. Object Beta was not a first contact envoy. It was not a greeting. It was not a warning. It was reconnaissance. Reconnaissance precedes decisions. That realization forced a reframing of the situation. The object had not arrived to communicate, it had arrived to observe, measure, and assess our technology, our emissions, our defenses, our behavior, and perhaps most importantly, our reactions. Because from the moment object Beta separated from Atlas, humanity had been responding quietly at first, then with increasing urgency. We had turned our instruments toward it, adjusted our radars, altered our procedures. In doing so, we may have already provided more information than we realized. As the sphere reached the threshold of Lagrange point 1, it executed its final insertion burn, a misnomer in this case, since there was no burn at all. It simply settled into position, motionless relative to Earth, the Sun, and the balance of gravitational forces between them. From that point forward, object Beta would never set, it would never drift out of view. It would remain fixed in the sky, invisible to the naked eye, yet permanently present, watching. And now, with the object in place, the waiting phase had ended. The observation phase had begun. Observation changes both the observer and the observed. That is a principle as old as physics itself, and now it applies on a planetary scale. With object Beta fully established at Lagrange point 1, the data stream did not increase, it narrowed. Instead of broad spectrum scanning, the emissions we detected became highly selective, focused on specific frequency bands tied directly to human technology, power grids, radar systems, satellite communications, deep space telemetry. It wasn't gathering everything, it was gathering what mattered. Within hours of station keeping, gravitational sensors aboard multiple satellites began registering rhythmic micro-variations. At first, they were dismissed as noise. But noise does not repeat with precision. These fluctuations followed a pattern, oscillating in intervals too consistent to be natural. Something at L1 was actively modulating the local gravity field, not enough to cause disruption, but enough to measure. This was not passive surveillance. This was calibration. At the same time, atmospheric monitoring stations recorded faint but global changes in ionospheric behavior. Nothing catastrophic, nothing visible. Just enough to confirm that the object's influence extended far beyond its physical size. It didn't need to enter Earth's orbit to affect us. Its position alone was sufficient. And then came the signal. 5 minutes ago, the Green Bank telescope detected a burst that defied classification. It was not radio. It was not microwave. It was not electromagnetic at all. It was a tightly collimated neutrino beam, lasting less than a second, but carrying an immense amount of encoded information. Neutrinos almost never interact with matter. They pass through planets like ghosts, which makes them perfect for communication across vast distances, uninterrupted by stars, dust, or time. The direction of the burst was unmistakable. Away from Earth, away from the Sunday, toward the constellation Cygnus, aimed precisely at a star system over 1,400 light-years from here. That detail changes everything. Because object Beta did not announce itself to us, it did not ask questions, it did not warn or threaten. It didn't even acknowledge our presence directly. Instead, it reported outward. Which means Earth was not the recipient. Earth was the subject. This was not a message meant for humanity. It was a status update sent to something else, something far away, something patient enough to wait centuries for an answer. The implications are staggering. The probe did not arrive to explore the unknown. It arrived to verify a hypothesis, to confirm that a technological civilization exists on this planet, that we emit signals, that we manipulate energy, that we alter our environment, that we are visible. And now, that confirmation has been sent. From a strategic standpoint, this is the most important moment in human history, not because of what has happened, but because of what may happen next. Scouts do not act alone. They precede follow-up decisions. Sometimes those decisions are benign. Sometimes they are not. Right now, the object remains silent. It has completed its task. It has nothing left to do but wait. And so do we. We are left with a question that has no precedent and no comfort. Not, are we alone? But, now that we've been seen, what comes next? Because whatever sent that probe now knows exactly where we are. If you want to stay informed as this story develops, if you want clear, grounded analysis without hype or panic, make sure you subscribe, turn on notifications, and share this with anyone who needs to understand what is unfolding above our heads. History may have just changed direction, and the next chapter hasn't been written yet.